There we go. Our next stream seems to be on. It's beautiful, beautiful. So let's start the stream and continue our courses. Okay, learning Python. So here we have made this project. There's no need to look at it more. Just gonna watch this video to compare our code and etc.
Is going to take the
So we were at so it's complete.
user score and also the computer score, and it's going to compare these two scores. If the user score is equal to the computer score, then we said this should mean that it's a draw.
It's a draw, yeah, exactly. LF, and if the computer score is equivalent to 0, return lose, which means it is blackjack, okay, etc. Then we are making all of these use cases, okay. Win with a blackjack, lose opponent has a blackjack, etc, etc. You went over, you lose, opponents went over, you win. That's kind of nice, but you know, it's enough. So let's see this video.
Hey, well done for completing your very first capstone project. Now I know it was a difficult project, but it's meant to stretch you just enough so that you're still struggling, but you still have all the components that you need to tackle it. Now in this project, we saw a lot of the things that we learned in the previous days being put into use, like while loops, for loops, functions, variables, everything all packaged together.
That's true.
Now, these are the fundamentals that you're learning in each of the days and each of the lessons, even though individually they seem very small. But when put together, you can create really interesting and really complex projects like the Blackjack project. So even though it was difficult and even though you had to stretch yourself, as long as you've got solid foundations, then you can continue and you'll be able to build even better things. So together, we're going to make sure that you have a really solid foundation before you continue, before we start building more fun projects like websites and data mining and data scraping and data visualization.
Wait, I'm going to learn all of that.
And all of that. So make sure that you review all the concepts that you've learned so far. And if there's anything that's not quite 100%, then just review the content, practice it a few times, and then continue. And you'll be so much better off for that solid foundation. So have a good rest, and I'll see you tomorrow.
Hey guys.
So we're going to learn about number guessing. So from day 11, we're gonna have this project introduced into the final project, the number guessing game. So there is another game that we have to develop. Let's do it.
Welcome to day 12 of 100 days of code. Now today we're going to be building a number guessing project, and we're going to be learning all about scope. So if you take a look at the final demo project for day 12, you'll see that we've got a guess the number game. So welcome to the number guessing game. I'm thinking of a number between 1 and 100. Now in the demo, there is a little bit of answer text, which you won't have in your final game, but this is just to make it a little bit easier for us to test this game. So the correct answer is 100, which we already know. Now, we're asked to choose a difficulty, easy or hard.
Okay, that's correct. All of that is correct. Okay, so welcome to the number guessing game. I'm thinking of a number between 1 and 100, but the correct answer is 100. Choose difficulty, type easy or hard, okay.
Now, if we choose easy, it means we have 10 attempts to guess the number. And if we guess a number and it's too low, it'll tell us that it's too low. And if we guess a number that is too high, then it will be too high. until we somehow figure out
Okay.
the correct answer, which in this case happens to be 100. Now, if we
This seems to be very easy. Why is this project seems to be very easy? I don't know.
go ahead and try the hard mode, you can see we only have 5 attempts.
Like, to develop this seems to be very easy because it is not that much of a difficult algorithm as it seems to be. That seems to be interesting for me, okay?
To guess the answer, and we have to be able to get there using these clues of low or high to try and guess the correct answer. So this is what we're going to be building, and in the process we're going to be covering a lot about scope, about global variables, about a lot of the stuff that we've sort of started to.
So, scope, global variables, I don't know these stuff. So we're gonna watch and learn and practice. And because this project seems to be very easy, I'm gonna try to grasp her way of organizing the code. Like, if we compared my code to her codes in the Blackjack project, she has more of an organization. She makes each functionality a function, so she defines for each functionality a function, unlike me. And I have to learn the skill of organizing code and making it more optimal and easier to maintain, okay? And more readable as well. Okay, so if we compared the solution, which is in here, so that's her code pre-written, and my code. So I'm just gonna make this happen real quick. Okay, I'm gonna comment out all of this. Beautiful. So this is my code. All of this is my code, which is crazy. Seems to be a lot, isn't it? So in total, it's like 80 lines of code. If you got rid of from these spaces, it's like 70 lines of code, approximately. And my functions are limited. Okay, so I share more than one functionality in one function, which makes them very harder to maintain or to add a new feature to this game. Okay, and here I have a storyline while loop. Okay, all of this is a storyline while loop. It is flexible if you wanted to add any card, etc., but it's not optimal. Okay, and in here I'm not checking for a blackjack, and a blackjack is like having 10 and 11. So if you had 10 and 11, you have a blackjack, the computer loses. So I have to make sure of that as well. I could add it, but it's not important. But we could see it in here at the solution. Oh, okay. She didn't write a solution for this project, isn't it? Let me make sure of that. No, she made it, I guess, yeah. Well, this is the right solution. Okay, beautiful. So here we compare. This is the blackjack that I said. If the sum of both cards, like 10 and 11, makes 21, and the length are just 2 cards, not 3 or 4 cards, then we're gonna return 0, which means you have a blackjack. And if the computer score was a blackjack, means that the computer won. If you had a blackjack, then you win. Okay, so I could just add that. Okay, and maybe add this as well to my code. So yeah, if I add this to my code, these cases of blackjack, then it's gonna be good or better, because here I am checking for blackjack. Okay, but I'm not catching the length of the cards, which makes so here if the computer and me got a blackjack, then it is a draw, right? That's correct. So yeah, my code is not that optimal for this game, but it's not that bad. It still works. So we're just gonna move to the next project, which is gonna be day 12. And we're gonna start by the task. And we're gonna delete this. Okay, beautiful. Okay, I'm just gonna toggle this out. Or N. Toggle N. And day 12 is toggled out. Okay. Beautiful.
To think about and to use in our code, but formally we haven't yet really approached. So that's what we're going to be doing. And once you're ready, head over to the next lesson. The first thing I want to talk about is a concept known in programming as scope. And this scope is something that we've actually come across already in our programming. But I wanted to leave it until we've seen functions, we've seen if and while loops, different types and blocks of code before we start talking about this really important concept. Now, if you want to visualize this concept, imagine you have a house with a fence around it and you plant an apple tree inside your garden. Think about who can access those apples. Just you and your family, right? But what if instead you had an apple tree in the neighborhood, by the sidewalk, for example? Well, this is kind of free for all. Anybody can go and access those apples. This is a starting point for how to understand scope. Take a look at the code that's in the starting file and try to understand.
Okay, let us grasp this. So we're going to understand the scope step by step.
Across already in our programming.
Okay, let's repeat all this. Beautiful.
The first thing I want to talk about is a concept known in programming as scope. And this scope is something that we've actually come across already in our programming. But I wanted to leave it until we've seen functions, we've seen if and while loops, different types and blocks of code before we start talking about this really important concept. Now, if you want to visualize this concept, imagine you have a house with a fence around it and you plant an apple tree inside your garden. Think about who can access those apples. Just you and your family, right? But what if instead you had an apple tree in the neighborhood, by the sidewalk, for example? Well, this is kind of free for all. Anybody can go and access those apples. This is a starting point for how to understand scope. Take a look at the code.
Okay, this is very interesting. It is the same terminology that we use in ethical hacking and cybersecurity in general, which is to define your scope before actually exploiting your target. Okay, you don't want to go over your scope, because if you did so, you might break the system and your employer could sue you because you didn't respect the scope given in your contract, etc. So very important.
Code that's in the starting file and try to understand what it's doing. First, I create a variable called enemies and I set it to equal 1. Then I create a function called increase enemies and I try to set that variable to 2. Finally, I call my function, triggering all the lines of code inside. And now I want you to predict, what will this print statement print in the console and what will this print statement print?
Okay, this is very interesting. Here we have this function, which is increase enemies. Then we have enemies set to 2. And then we are printing this. Okay, if we call this, we're gonna get this printed out. Enemies outside function. Enemies outside function is gonna be 1, okay? So here 2 and 1, okay? Very easy.
and it might not be what you expect it to be. So I would
That's impossible. It's the right thing that I've expected. Okay. Here, it's gonna be 2. Here it's gonna be 1. That's how code functions. I expect everything.
expect that here I've got a variable which is equal to 1. When this function is called, this variable enemies should now be equal to 2. So when it's printed down here from outside my function, this should be equal to 2, and this should also be equal to 2. But look at what happens
No.
instead. I get,
As I said, because inside the function we have a new environment. Outside the function we have another environment, okay? So the enemies inside of the function has its own RAM, its own memory in the low machine. And here we have another memory, okay? And what gets executed inside of the function is shared inside of the function, okay? Not outside the function. In the opposite direction, that doesn't work, okay? For example, if we had here in Python, let me just comment out all of this. If we had a list, like a list that has this string, for example, this, okay? And we define this function like name, need a column, okay, beautiful. So after we have defined this function, we could manipulate this list and print it. So return random.choice list, beautiful. That is gonna work for my case. Import random, beautiful. So here we could use the memory outside of the function, which is this list. It exists outside of the function, which has, so this is the global memory of the code, okay? And inside the function there is the function's memory, and inside of this function we have the list, and we could access the global memory whenever we want. But the opposite doesn't work, because if here we had another list, okay, and we didn't have these names, maybe we had only Ace, okay, so in this case we are going to prioritize the memory inside of the function, and our memory has a variable that is assigned to this list, okay? So as simple as that. We could access the global memory inside of a function. That's absolutely possible. But we cannot access the outside memory. We cannot access the internal memory of the, let me just show you again. We cannot access this internal memory, but so let me show it. So I've printed name and I've printed the list. Hold on a second. Yes. Here we go. So here we are not taking this in the global. We are taking this one, this definition, this assignment. I'm not taking this assignment, as you could see in this print statement. Beautiful. So this list, this is the internal memory of the function. We cannot access that in the global memory, okay? But the function can access the global memory, but us, outside of the function, we cannot access the function internal memory, but the function could access the external memory, okay? Like this, okay? Beautiful. Hold on a second, what's happening here? Are taking the list, which is Ace, etc. Yes, so we are choosing random element from the list. So this is functionable. Easy.
enemies from inside the function equal to 2, but from the outside the function it's equal to 1. So what's going on here? To really understand this, we have to understand the concept of scope. And scope is a really, really important thing in programming. You see it in every programming language. And although it's a little bit different between the programming languages, it all goes back to that concept of the apple tree being within a fence or outside a fence. So let's take a look at some other examples before we come back to solve this problem. The first thing to think about is a concept called local scope. Local scope exists within functions. So for example, if I was creating a game and I had a function called drink potion, which is somehow going to strengthen my player, well, maybe it would have a variable that's created inside the function. So it could be something like potion strength, and I could set that to start off with a value of 2. Now, in this case, if I was to go and print this variable potion strength from within the function, notice I'm indented here. And of course, I need to call this function for that to happen. Notice what happens when I run the code. It's equal to 2. That's what we would expect, right? But notice what happens if I try to print the potion strength from outside the function, here. This firstly gives me an error right when I'm writing it inside the editor. And when I try to run it, it gives me an error inside the console. And the error is a name error. And it tells me that the name potion strength is not defined. Clearly, I've defined it here, but why can't I access it outside the function? Well, this goes back to the concept of local scope. When you create a new variable, or indeed a new function, inside another function, it's only accessible. You can only use it when you're inside that function because it has local scope. It's only valid within the walls of
Scope or memory, same term.
this drink potion function. What if we wanted it to be accessible outside the function? Well, now we need to think about something called global scope. The only difference between global scope and local scope is where you define or where you create your variables or your functions. So let's say we have a different variable. Let's say that I created a variable called player health, and it starts off being equal to 10. Now, let's say later on I have the same drink potion function, and this potion has strength of 2. So now, inside my function drink potion, if I wanted to print my player health, even though it wasn't defined within the function, this is perfectly possible. And if I call my function drink potion and then run the code as it is, you'll see 10 being printed. So
I don't know why, but this is crazy obvious.
this has a global scope. It's available anywhere within our file because it was defined at the top level of the file. Now, when I say top level, I don't mean physically at the very top of the file. I mean that it's not within another function, like potion strength here, because this is defined indented inside a function. So this is a local variable, whereas this is a global variable. And
That's what I'm talking about. Local, global. Yeah.
global variables are available within functions, no matter how deep it gets nested, and it's also available outside of functions. This concept of global and local scope doesn't just apply to variables. As I alluded to before, it also applies to functions and basically anything else you name. This is a concept called the namespace. So we defined this variable player health. We defined this function drink potion. Anything that you give a name to has a namespace. And that namespace is valid in certain scopes. This concept of scope applies to basically anything you name. If I was to nest this function drink potion inside another function, let's call it game, well, this drink potion now has local scope within the function of game. So this is why this line is now erroring out, because it can't actually see inside this function. So now, in order to call this drink potion, I have to be within the four walls of the game function. So whenever you give name to anything, a function or a variable, you have to be aware of where you created it. Now, it's easy to notice where you've created functions. We have the def keyword, right? But when you create a variable, that's the first time that you give it a name and you set it equal to something. And where you write that line of code defines the scope of that particular variable. Here, it's outside of every other function, whereas here, it's inside a function, actually nested 2 levels deep, so it has local scope to this function.
Beautiful.
Now, unlike some other programming languages, if you've come from, say, C++ or Java, there is no such thing as block scope in Python. What this means is that if you were to create an if statement, say if 3 is greater than 2, and if you were to create a new variable inside an if block or a while loop or a for loop, basically any sort of block of code that's indented, this does not count as a fence. It still has the same scope as its enclosing function, or if there's no enclosing function, then it has global scope. So let me show you a full example. Let's say we had a list of enemies. So the enemies could be skeletons, zombies, or aliens. So now if I was to define a game level, right, like the level that the user is currently playing at, let's say they're on level 3, and I create an if statement and I check if the game level is less than level 5, well, in that case, I want to create a new enemy, but I don't want the enemy to be too difficult to beat. So I'm going to pick from the list of enemies, and I'm going to pick the first one. Notice how even though this new enemy is a variable that's created within this if block, if I go outside...
Okay, so this new enemy, even if it was inside of the if statement, defined inside of it, we could still use it as global variable. So you could actually just get this list and see. So we have already a list. I call it maybe game level. I don't want to think about anything right now, so I'm just gonna copy this really quick. So it's gonna be 3. So F game level was below. Hold on a second. It was below. Beautiful. If it was below 3 or 5 or 6 or wherever, then we are gonna make a new variable called new, and we're gonna just grab something from that list. Okay, let's grab something. I'm gonna grab the first index 0, and let's print this new variable. So it is still a global variable because we could access it after the if statement, which is very obvious. And there we go. The very first thing, which is ace. Beautiful. Easy.
The if block, so I'm not indented at all anymore, and I try to print this new enemy. This is perfectly valid code, and if I run the code, you'll see skeleton being printed. But notice how as soon as I embed this within a function, so let's define a new function, and now this line errors out. Because within the function there is local scope, so now this new enemy is available anywhere within this function, because blocks like if, while, for, all of these blocks of code with colons and indentation, they don't count as creating a local scope. So in order to print this new enemy, I actually have to be within the boundary of this function, which means my code has to be here. The most important thing to remember from this is if you
Okay, beautiful.
all of these blocks of code
So yes, all of those definitions inside of the function are local,
with
and you cannot access them as global. Okay.
colons and indentation, they don't count as creating a local scope. So in order to print this new enemy, I actually have to be within the boundary of this function, which means my code has to be here. The most important thing to remember from this is if you create a variable within a function, then it's only available within that function. But if you create a variable within an if block or a while loop or a for loop or anything that has the indentation and the colon, then that does not count as creating a separate local scope.
But one thing you might see when you're using some variable that is defined within a block, such as an if or a for, is you might get this warning from the linter, which reminds us how to write good Python code, that the local variable might be referenced before assignment. So it's basically saying, well, what if the game level is not less than 5? What if it was like 10? Well, in this case, if we try to run this code, this print statement will never be executed because
this has been defined in this case only. Okay, because this code has been skipped, because this if statement is false, so the interpreter is gonna skip all of this. And if we would print this, we would print none, which is nothing.
this if statement is not true, so this variable new enemy is never created. So then what are we printing here? We're printing nothing, just air, right? So in order to get rid of this warning, what you can do is outside of any blocks, such as if or while, you can declare and create that variable
Maybe it could be an empty string, who knows?
and initialize it. So let's create new enemy and set it to empty. Well, in this case, what it sees now is that there is a new enemy variable. It has been already created, and depending on these conditions, it might be modified, but it will always be able to be accessed. So the outcome doesn't really change, but the linter sees these situations where something could potentially go wrong and is just reminding you. So you have two choices. You can ignore it if you know what it's saying is complete rubbish because you know your code better than it does. Or you can follow its orders and simply initialize the variable before you ever use it. And instead of creating the variable inside a block that may not be accessed.
Beautiful to know. Okay. Okay, so we have this exercise. Prime number checker. Prime numbers are numbers that can only be cleanly divided by themselves into one. Oh, okay. So prime number is like 1. It could be divided by himself into 1 as well. 2, if you divide 2 by 2 is going to be clean. And by 1, it's not going to be clean. What about 3? Okay, let me check these prime numbers, so I don't have to think about them. Prime numbers. Go to an image. We have here the Wikipedia. Okay. So these are the prime numbers. Okay. So 2 by 2 is 0, which is clean. But let's read more of this. So prime numbers are numbers that can only be cleanly divided by themselves into 1. Okay. That's weird. What's about 3 sine 5? Okay. Let's see. Let me ask AI about this. What's our prime numbers? Prime number is a positive integer, then 1. Okay. That has exactly 2 distinct positive divisors. Okay, 1 in itself. In other words, a prime number cannot be formed by multiplying two smaller positive integers. Key points about prime numbers. Greater than 1, the number 1 is specifically excluded from being a prime number because it only has one divisor itself. Interesting. Divisibility: if you divide a prime number by any other positive whole number besides 1 in itself, you will get a remainder. Oh, interesting. Interesting. Okay, how to express, to actually express that, we're gonna use the modulo. So we're just gonna do that by ourselves. If you divide a prime number by any other whole number besides 1 and itself, okay, you will get a remainder. Okay, interesting. Saying maybe number 2 is a prime, right? Because if this number, let me set this number to 2, for example, num equivalent to 2. So if our number by another positive whole number besides 1 and itself, you will get a remainder. Okay, so if we divided this number, cannot access it. Okay, not a problem. Okay, beautiful. Well, I'm not a math guy. I don't like math that much. Okay, let me ask him how to express that. Express that with Python. Let's see. Okay, express the concept of checking if a number is prime is Python with a function. Define it as prime.n. If the number is below 1, return false. If number is equivalent to 2, and if this number modulo 2 is clean, return 0. Any other even number is not prime. Okay. Check for all divisors from 3 up to square root of n. We only need to check up the square root because if it has a factor larger than its square root, it must also have a factor smaller than its square root. So we have this. So while 6 is smaller than our number, and if the number is modulo this was clean, which is a clean division, they are going to return false. Otherwise, only check odd numbers. Beautiful. If no divisors were found, then number is prime. Okay. Well, as I said, I don't care about math, and anything that challenges me to do math, I hate it. I'm not a math guy. Okay. So we are having this function over here. Could replace that easily. Beautiful. Okay, so the first thing we check, if the number is smaller than 1 or equivalent, then we don't want these type of numbers. We are going to return false. Okay, etc, etc. So only after we have catched all of these cases and catched this case as well using the while loop. Okay, which is then its square root. It must also have a factor smaller than its square root, which is pretty interesting. I don't know if I need this at the moment, so I'm just gonna comment it out. Seems to be a little bit complicated. Okay, so I need to write a function called isPrime that checks whether if the number passed into it is a prime number or not. It should return true or false. Okay, 7 is a prime number because it's only divisible by 1 and itself. So any number that is even is never going to be prime. We're just checking for odd numbers. Okay, that's why we catch this case. So 2 is only even number. 2 is only even number because if we divide it 2 by 2, it's gonna be 1, and if we divide it 2 by 1, it's gonna be null, which is 0, 5, right? As I said, I'm not a math person, but it's alright. It's Python. That's why there is Python. Okay, so 2 divided by 1. Oh, we have 2. Am I stupid? Yeah. By 1, it's gonna be 2. Oh, I have meant to. Oh, okay, that's stupid. That was stupid. So 2 by 2 is gonna be 1, and if you have divided 2 by 1, I mean that it's gonna be 2. Okay, because of this case. So if we divided the same number by itself, it's gonna give us 1, and if we use this result and divided it by 1, it should give us 2, which is the same number. Okay, we're gonna use this rather than using all of this. I'm just gonna comment all of this out, and let's see if we catch this, because it's gonna be very unique if we did. Okay, so if our number is divisible by itself and give us 1, so if our number is divisible by itself, so if number divisible by itself, okay, I know this is way simpler and stupid. So number divided by itself should give us 1. That if it was equivalent to 1, okay, and if we took that number and divided by 1, and took that number and divided it by 1, then we're gonna return true. This is if it was actually equivalent to let's see here, yes, so the number to itself, which is the number, then we're going to return that. Otherwise we are gonna return, I know this is silly, stupid, I don't care, I'm not a mathematician, it's gonna be false. Let's see, let's run the code and see what's gonna happen. Run completed, the results, don't see any error. Okay, let's see this prime number, this not prime number. 75 is not a prime number. Oh, okay, so the first test was true, was correct. Okay, So let me ask AI if my algorithm was enough. I didn't expect it for any test to be passed, but it did pass somehow. Okay, why this algorithm fails? Then we have this for this case. Okay, let's see what's the reason. Okay, let's see. Okay, the code snippet you provided would always return true for any integer greater than 1, and it doesn't check for primality correctly. Okay, furthermore, it mixes boolean and tuple returns types, which is generally bad practice and will cause issues if you try to unpack the results. So if we said here, okay, logical flaw in the condition you are testing is this and this. This analyze was this, okay. For any positive integer, dividing by itself is integer, division always results in 1. Okay. That's true. Okay. Okay, so I see the flow. Okay, what if we did the same concept with 7? To just check that out. 7 divided by 1 is gonna give us 7. 7 by 7. So each integer would apply to the same concept. Okay, interesting. Since both are true, the function returns true and correctly identifies 75 as prime. Okay, error return types, else block. This second issue is the else block. Okay, if condition were ever false, which won't be for numbers which are positive, you attempt to return a tuple containing the boolean false in the string. Okay, if your function is expected to return a single boolean value like true or false, trying to return a tuple like well, cause an error when you try to use the result as a simple boolean later. Or if you are experiencing a single value. Inclusion algorithm provides not a prime checking algorithm. It simulates that confirms the mathematical integration. Okay. So, which means I'm stupid. Okay. Well. Let me access Udemy and see. Let us learn about this. So example, input 1 31 is 73. Output 1 is true. Input 2 75. This one is false. Okay. Okay, interesting. What's the difference between these and these? Let me read this again. You need to write a function called that checks whether if the number passed into it is a prime or not. 7 is a prime number because it's only divisible by 1. And itself. Maybe if we use the modulo. So this thing is divisible by itself. It's gonna give us a 0, right? Prime is a number because it's divisible by 1. And itself, if you use another modulo in here. And 1, yes, exactly. This would give us another 0. Let's test it out. Like, don't blame me. I'm just not trying to use what AI said. Trying to do my own stuff. Okay. See if that would work. So that does not do anything. Okay. 4 is not a prime number because you can divide it by 1, 2, or 4. No, 2 is a prime number because it's only divisible by 1 itself, but 1, okay. I gave up. I'm not a mathematician. Fuck this shit. I'm just gonna use what the AI said. Sorry. From here, comments out, everything. Let's run the tests. Well, this should work, right? Nah, didn't work for both of them. And it's not defined. Oh, okay. What a simple, stupid error. I'm just gonna change this to n. Let's run the tests again. Let's see. So it still fails for this number. So let me uncheck all of this. I'm not a mathematician and I don't care. I'm gonna delete this. Beautiful. Let's run the tests. Beautiful. And we passed. Success. Who cares? Blah blah blah. The shittiest exercise out there.
Coming back to our
Okay, I don't know why she gave us this coding exercise, because it's more like algorithm math exercise rather than coding exercise. I didn't enjoy it, and we didn't have enough hints. For me, I'm not a mathematician. I don't develop algorithms. I don't care about them. And yeah, I used AI for that. Who cares? Okay. So, so we have this video to modify a global variable, Python constants in global scope. Then we have a quiz, and then we have an introduction to the project. So the introduction and all of this, I'm gonna do it tomorrow. I'm just gonna do these 3 videos and that's it. Tomorrow we're gonna have this. Okay. Alright, I think I could do the final project because it is an easy project, I don't know. So I'm gonna see the introduction and judge if it was difficult or easy. Depends, okay.
original example, I want to talk more about the global scope and the concept of modifying something within the global scope. Here we have enemies, which is a variable that has global scope. And here we have a function which creates a local scope. Now we think that we're tapping into this variable and setting it to 2. But in fact, we're actually creating a completely new variable that's entirely separate from this one. And this is why when we printed it here, it showed it was equal to 2. But when we printed it here, it showed it was actually equal to 1. If you want to make this a little bit more obvious, I can call this a skeleton, and I can set this to be a zombie. And when I hit run, you can see again, this prints zombie, this prints skeleton, because these 2 variables are actually entirely different things. And we're not changing this right here at all. We're just creating a new variable that has a local scope. Now, it's usually a terrible idea to call your local variables and your global variables the same name. But in this case, what we actually wanted to do was we wanted to modify this variable. We wanted to do something like maybe plus equals 1. And notice how as soon as I write plus equals 1, then my editor starts going crazy and tells me that this local variable
Doesn't exist.
enemies is defined.
Okay. So here, enemies is defined in here. But for some reason we have an error. Okay, interesting. Wow, okay. For some reason we have an error.
Defined in an enclosing scope is referenced before assignment. What does that mean? It means that the editor thinks you're trying to tap into a local variable that you defined somewhere around here. And then you tried to modify it by adding 1 to the previous value, but you actually haven't defined it. What we wanted to do though is we wanted to
Yes, edit this one. That's true.
tap into this variable and change it here. in order to do this, we actually have to explicitly say that we have a global variable, which is called enemies, that's defined somewhere outside of.
Oh, that's why you should use this global keyword. Oh, okay. This is uniquely. What about local variables? For example, if we had a local variable, maybe, let me delete all of this. It's unnecessary, okay? Just blah, blah, blah. Okay, here. I'm gonna comment out all of this. So, do these here global, right? Global. Okay. If we didn't use it, then so here we are having this error, and here let's move around this invalid syntax. What are you talking about? That's not an invalid syntax. What are you talking about? Interesting. So you have to call. Okay, I understand what this means. Okay, so we have to call this variable from the global scope, and then we could work with it in the local scope. Otherwise, we're gonna have an error. Okay, beautiful. But what if we used local in here? So rather than this, maybe for some reason I want to make this local. Is that possible? Nah, there is no keyword for that. Okay, so the opposite isn't possible. Makes sense.
Of this function, and that is the enemies that we want to use inside this function. So it basically takes that global enemies into the function and allows you to modify it. Without this line of code, we cannot modify something that is global within a local scope. Now, there's a reason why it's so difficult to modify something that has global scope. You probably don't actually want to do this very often because it's confusing and it's prone to creating bugs and errors. Because this variable with global scope could have been created anywhere in your code, right? And you would be modifying it completely independent of when you created it. So it might have been days between when you wrote this code and when you wrote this code, and it just makes everything more fallible, more easy to fail. This is why very often people will tell you when they're teaching you Python to avoid modifying global scope. You can read it, that's not a problem. You can use it within your code like we are here, but don't try to modify it within a function that has local scope. But what can you do instead? What if you wanted to have this functionality, like a function that changes the number of enemies? How can you achieve this without modifying the global scope within the function?
Is that even possible?
Well, you could use what we learned about return statements instead.
Okay, let me think about that. We could make an input, which is, oh my god, this makes sense. Instead, I could make here an input for this. Come on, man. Let me write my code. Okay, so var, so this is a variable, and I'm gonna use this variable. It's gonna be assigned to. Come on, man. What's this keyboard being so much strange for me? Okay, so I'm gonna add. This is so much exciting. Then I'm gonna go here. Make this variable, and I'm gonna go and return all of this. Okay, beautiful. Return. Okay, this return has not been correctly intended. Yup. Okay, that's fine. Okay, then we're gonna use our global variable in here, and like this, it's gonna go from being global into being a local variable. We're gonna do our execution with it without modifying it in the global scope, which is true. Then we are having let me just print this out. Come on, man. Beautiful. Let's print. So yeah, we are having here 3. So it works. Beautiful.
Right? What if instead of modifying the enemies, you actually just simply returned it as the output? So return the current value of enemies plus 1. Now, once you call this function, you'll get hold of the outputs and you can save it to the global variable enemies. So this now means that this function can be taken away and placed anywhere in your code, and you don't actually need to know how it works. As long as you know that this is how you increase enemies, then all you have to do is just call it.
Okay, beautiful. Let's go to the next video. Python constants in global scope.
Remember, you should be careful with variables that have global scope, but don't believe the people who tell you that you should never use global scope. Global scope can be incredibly useful, especially when you're defining constants. Global constants are variables which you define and you're never planning on changing it ever again. It's just something like, for example, the value of pi, right? You want to look it up once and you want to put it into your code and you never
Okay, this is interesting.
want to look it up ever again. And
Because our variable is gonna stay constant, which makes this variable not a variable anymore, just a memory that is constant. Okay, so it doesn't matter if you modify, because you're never gonna modify that. It doesn't matter if you use the global in a local scope, which is the global scope inside the local scope, etc. Doesn't matter because it stays constant. So it's never gonna change.
every other time you want to use it, say inside a function, then all you want to do is just tap into that value of pi. So usually, in order to differentiate these constants, which you're pretty much never going to change, from the variables, which you're likely to change, the naming convention in Python is to turn it into all uppercase. For example, if you had pi or you had a URL that you needed to use, then these are all going to be uppercased, separated with underscores. What this means is that later on in your function, and you want to use one of these.
Okay, to differentiate between constants and variables, we could use uppercase and lowercase. Well, this is something that I didn't know. Okay, let's go. Let's make that happen. Okay, I'm just gonna go and add this over here as a quote. We could use uppercase for defining constants and lowercase for variables in Python. That's pretty interesting. See if there's a cool emoji to use for that. Yeah, it's gonna be the teacher emoji. Seems to be fun. It's gonna be a black teacher. Beautiful. Okay, cool.
Global constants. As soon as you type it, you can see it's uppercase and you know to remind yourself to not modify this inside your code. Now that we've talked a little bit about scope,
That's why we're gonna use the global, which is a constant, doesn't matter.
it's time
Never gonna modify it, so who cares?
to put your knowledge into action. Head over to the next lesson, and I've got a quiz that will test your understanding. So for all of that and more, I'll see you there.
Thank you for the quiz. It's gonna be way better than this heavy math exercise, prime numbers, which is something that I'm never gonna build. Who cares about such a useless algorithm, right? We want to develop cool stuff, right? Not boring mathematical algorithms about numbers. I'm not a mathematician. Okay. What will be printed in the console when the following code is run? Do not run the code, just pretend to be a computer. So we're going to define a function, a parameter, a variable. Return a parameter. Okay. So we are defining a new variable that we are not even using. And here you are giving 10, and we are returning 10 as well. So we're gonna have a 10. A variable doesn't make any sense in this case. What? Okay, let's see. It's trying to print a variable that is local to a function and is only available inside the function. Okay. So it's trying to print a local variable that is local to a function. Okay. It's only available inside the function. So a function is gonna be 10. Okay. I thought the print statement was in here. I'm stupid for that. Because this is very easy. It's gonna print an a variable, and a variable is not defined. So it's gonna be syntax error or name error, one of the both. Okay, I don't care. This is gonna be an error, both cases. Okay, that was stupid for me. What will be printed in the console with the codes is run. Do not run the code, just pretend to be a computer. Here we have 50. I'm going to define a foo function. And we have this variable, which is 50. It's now going to be 100. We're going to return it. We are calling this function. Okay. So it's going to be 50, easy peasy. Because this is a global variable. And this is a whole new local variable inside of the function, and the function actually returns e, but it is not being printed, it is just returned, and that's it. Very simple. Here I'm defining this variable, this function called bar, and this variable has 9 assigned to it. Then we have an if statement, f16. Okay, this is true all the time because 16 is greater than 9. My variable is going to be equivalent to 16. So because this all the time is true, this variable is now assigned to 16. Then we're going to print this variable, it's going to be 16. We are calling this. Nothing will be printed because, hold on a second, we are calling this, we are not returning it. So we're gonna have 16. Beautiful. Easy. Okay. We could continue.
Now that you've...
Okay, I'm gonna do this for tomorrow. Okay. Do this. And we're gonna start this 13. We're gonna learn about debugging, etc, etc, etc. Okay. So for the day, this is enough. And till tomorrow. Goodbye.